Hello, welcome to Accounting Hub. I'm Professor George Scarpin, PhD in Accounting, and our topic today is factor resource constraint. What does it mean? I have some products, more than one, two or more, and I am not able to produce the amount of units I want because I have constraints. Direct labor constraint, machine hours constraint, and so on. Our video today is when we have one and only one constraint. If we have more than one, we have a second video for that, and this video is in our video description. Okay. To make it easier, let's go to our Excel file that is also on our video description because all of our Excel files, they are free to download. Let's consider here product 1 and 2. Product 1, sales price 30, variable expenses 12, contribution margin 18, contribution margin ratio 60%. Product 2, sales price 60, variable expenses 48, contribution margin 12, contribution margin ratio 20. The same info here, okay? We will work with this info later. We are able to produce 10 units per machine hour for product 1 and 20 for product 2. And this is our constraint. We have only 2,000 machine hours. And which product is more profitable? Product 1 or product 2? If we have no constraint, product 1 would be the most profitable one. However, we have this constraint. And how do we find the most profitable product? We start with the contribution margin 18 and 12 multiply by number of units that we are able to produce per hour 10 and 20, and now contribution margin per machine hours, contribution margin per unit multiplied by number of units per machine hours. Wow, now product 2 is the most profitable one, because if we work one machine hours, we will earn $240 for product 1, for product 2, and only 180 for product 1. And how much is our maximum contribution margin? Let's produce only the product 2, so let's work with the 2,000 hours for this product. So our contribution margin at full capacity, margin per hour times number of hour, nothing for product 1, 240 times 2,000 machine hours, 480. So how many units are we producing? Contribution margin per hour times the number of hours. Oh, sorry. Uh, Number of hours times the units per hour. Nothing for product 1, 2,000 times 20 for product 2. So 40,000 units. To check if it's right or not, for 40,000 times contribution margin per unit, the same for 80 here. However, let's consider that our demand here, it's only for 25,000 units. If we are work with only 25,000 units, what do we need here? We will be working with uh, how many hours do we need? We need 25,000 divided by 20 units per hour. So we would be using only 1,250. And then now we have 750 hours free to produce product number 1. And then here we would be working with the 2,000 units, 2,000 hours, sorry. Okay? What is the difference between this second sample here? If we are able to produce 10 units per hour, we need zero point 0.1 hour per unit for product 1, 0.05 hours per unit for product number 2. This is the most usual one, especially if we have more than one constraint. And our math is the same. Contribution margin per unit 18, contribution margin per unit 12, number of machine hours per unit 0.1, 0.005. However, now if we are talking about machine hours per unit, our contribution margin per machine hour will be 18 divided by 0.1. So 180, 240, and then here we have the same formulas and so on. So here the same formulas as we have here. Okay, and then if we have demand, we do exactly the same. Okay, guys. So thank you so much. If you have questions or comments, leave it here or email me at jscarpy@gmail.com. Subscribe our channel, like our video, and have a very nice day.